So before going to solve this exercise 2.5 in that question number 1, this one, so we will understand what is the division algorithm for the polynomial. So division algorithm for the polynomial, as we have already seen that we know the algorithm to divide the two numbers. Suppose in the same way, if p of x and g of x are any two polynomials with g of x is not equal to 0, that is p of x divided by g of x, where condition is g of x should not be equal to 0. If it is equal to 0, then what happens? The value will become infinity. So hence, then we can find the polynomial, that is q of x and r of x. Here q of x is nothing but quotient, r of x is nothing but remainder. So if this is the polynomial, means if p of x is the polynomial and g of x is the polynomial such that g of x is not equal to 0, then we can find out the values q of x and r of x. Okay, where r of x is equal to 0, or degree of r of x should be less than the degree of g of x. Okay. So we can find this result is known as division algorithm. This result is known as division algorithm for the polynomials. So we can understand if p of x and g of x are the two polynomials such that g of x is not equal to 0, then we can find the q of x and r of x, where q of x is the quotient, r of x is the remainder, such that r of x is equal to 0, or r of x degree is less than the degree of the g of x. This one. Okay. Now we will solve the one of the exercise so that we can understand better. Such is the case, then p of x can be written as g of x into q of x plus r of x. This can be best understood by, see here, suppose 20 divided by 3. If 20 is divided with 3, then 3 6 is 18. Okay, this will be 2. So if this is g of x and this is considered as p of x, then this will become the q of x and this will become r of x. So the equation for this can be written as 20 is equal to 3 into 6 plus 2. In the same way, we can write p of x is equal to g of x into quotient, that is q of x, plus remainder r of x. So in this way we can write. Okay, we will solve now this question number 1. So now in this question number 1, p of x is given, g of x is given. So p of x, that is x cube minus 3x square plus 5x minus 3. So this we will divide. Okay, here x square minus 2. So x square minus 2 means the degree of this is less and the degree of this is more. So now we will multiply with x into this one, so that x cube minus 2x. Here better we can write like this. In this way also, x cube, here minus 2x means we will write minus 2x here. Okay. So now x cube minus 2x. So how we will subtract? This one, interchanging the sign, this is plus. So x cube and x cube cancels. So minus 3x will, x square will be like this only. So this is plus 7x minus 3. Say minus 3x square is there. So here minus 3. Okay, minus 3 into x square minus 3x square minus 3 into minus 2 plus 6. So plus 6 we will write here. So this is cancelled. Interchange the symbols. 7x minus 9. Okay. So this is remaining. So here p of x is equal to this one, g of x is equal to this one, q of x is equal to this one, and r of x is equal to this one. Q of x is equal to x minus 3 and r of x is equal to 7x minus 9. That's all. Because one thing we have to keep it in mind that this, the degree of this one, that is 3, is the degree is 3, and here the degree of this one, that is degree of the dividend, must be greater than the degree of the divisor. So then only it is possible. We have to stop the division as and when the degree of this remainder is less than the degree of this divisor. Then it will be stopped. So we will go for next question. So here p of x, that is x to the power of 4 minus 3x square plus 4x plus 5, 4x. So here g of x equal to x square minus x plus 1, like this I have made arrange. X square minus x plus 1. Okay. So the degree, you see here, degree is 4 and degree is 2. This is possible. So x square, x4 means x square we will multiply. X square into x square, x to the power of 4. Then x square into x cube minus x cube. X cube is not here. Okay. So we will write x cube like this only. And x square plus 1 is equal to plus x square. That's all. And you will change the symbols. So here x to the power of 4, x to the power of 4 cancel. You see here, you should not confuse here. This is x cube and the x cube portion is not here. There is no x cube portion here. So we will write as it is x cube. See here, plus is there, plus x cube, and here minus 3x square. This is minus x square. So minus 4x square plus 4x plus 5. This portion I have written as it is. So now we will go for, this is x cube. So 1x, that is plus x, we will multiply. So plus x means x into x square, x cube minus x square plus x. So minus plus minus. So this is cancelled. Minus 4x square plus x square minus 3x square. Here minus, this is plus. So plus 3x plus 5. Now we will multiply with minus 3. Minus 3 into x square minus 3x square. Minus 3 into minus x plus 3x. Minus 3 into plus 1 minus 3. Okay. Plus minus plus. This is cancelled. This is also cancelled. Plus plus. This is 8. Okay. This q of x is equal to x square plus x minus 3. R of x is equal to 8. Okay. So now we will go for third one. Now we will go for this third one. X to the power of 4 minus 5x plus 6. So here minus x square plus 2 I have written like this. Just interchange. X to the power of 4 means this is square. So x square we will put. So here minus it is there. So we will minus we will take. So that it will become plus. X to the power of 4. So here minus x square plus 2. Okay, x square minus 2x square. Okay. So this plus become minus, minus become plus. So here 5x and plus 6 terms are there. We will write as it is. So x to the power of 4, x to the power of 4 cancels. So this plus 2x square plus 2x square, and x term is here 0. So we will write minus 5x plus 6 as it is. So now 2x square, here minus x square is there. So minus 2 we will take. So that it will become plus 2x square. Okay. Minus 2 into plus 2 minus 4. Okay. This is minus, this is plus. So this is cancelled. So here minus 5x. Okay. Plus 10. So now the degree of this one is less than this one, this degree. So now the division stops here. Here R of x is equal to 5x plus 10, that is minus 5x plus 10, and q of x is equal to minus x square minus 2. This is the answer. Here now exercise 2.3 in that question number 2. Check whether the first polynomial is a factor of the second polynomial. Well, that is this polynomial and this polynomial. This is the first polynomial, second polynomial. This is first polynomial and this is the second polynomial. We have to check whether this first polynomial is a factor of this one or not. So how to check it? For that, suppose if 2 and 7 are there, whether this is a factor of this one or not, how we are going to check? Suppose 7 divided by 2. Then what it is? 7. So 2. 2 3 is 6. Remainder will become 1. So here, if remainder is, that is remainder is not equal to 0 means, so this 2 is not a factor of 7. If remainder is not equal to 0 means, 2 is not a factor of 7. In this way we can decide. So if you divide one polynomial or one number into the other number, then if remainder comes 0, then it is a factor of that other. In the same way, these polynomials can also be done in the same way. Here two polynomials, suppose 2 and 6 are there, then 6 is divided by 2 means, so 6, 2, 3 is a 6, remainder will become 0. So remainder equal to 0, remainder equal to 0 means, so 2 is a factor of 6, factor of 6. In this way we can do. In this way we can decide. So in the same way, we will go for solving this first question. 2t4 plus 3t cube minus 2t square minus 9t minus 12. Okay, this one we will divide with t square minus 3. T square minus 3 means we have to see this degree of this one is less, so we can perform this operation. So now t square into t square, t to the power of 4. It is 2 is there, so 2t square. So 2t to the power of 4, okay, minus 3 into 2t square, 6t square. Here minus 6t square. We will write t square in this way. Okay. So here minus plus. This cancels. This plus 3t cube we will write as it is. So this is plus, this is minus. 6 minus 2 is 4. 4t square minus 9t minus 12. So 3t cube is there plus 3t. So 3t into t square, 3t cube minus 3 into 3, 9t minus 9t. So here minus, this is plus. So this is cancelled. 4t square. Okay, this is also cancelled. Minus 12. So now t square. Here plus 4 will multiply. 4 into t square, 4t square. 4 into 3, 12, minus 12. So this is minus, this is plus, this cancels. So it becomes 0. Here the remainder is 0 means, then we can say that t square minus 3 is a factor of second polynomial. That is, first polynomial is a factor of second polynomial. Like this. This is a factor of this polynomial. In the same way, we will go for second one. Second polynomial, 3 into x to the power of 4 plus 5x cube minus 7x square plus 2x plus 2. So this to be divided by x square plus 3x plus 1. So x square, here 4 is there, here 2 is there. So x square, if you multiply, it will become x to the power of 4. So 3x to the power of 4. 3x to the power of 4. So plus 3x square into 3x. 9x cube. Okay. Plus 3x square into 1. Plus 3x square. So here minus. So this cancels. So 5x cube minus 9x cube means minus 4x cube. This is minus. So minus 10x square plus 2x plus 2 as it is. This is as it is. So now minus 4x cube is there. So minus x, that is minus 4x. So minus 4x cube minus 4 into 3, 12x square minus 4x plus 1, minus 4x into 1 is equal to minus 4x. So here plus, this is plus. So this is cancelled. Plus 10, minus 10 plus 12. So 2x square plus 6x plus 2. So here plus 2 will multiply. 2 into x square, 2x square. 2 into 3x, 6x plus 2 into 1, 2. So this is minus. So this won't cancel. It will become 0. So again, remainder equal to 0. Hence, the first polynomial is factor of second polynomial. Okay, we will go for third one. So here x to the power of 5 minus 4x cube plus x square plus 3x plus 1. So this to be divided by first polynomial, that is x cube minus 3x plus 1. So x cube x5 means x square will multiply. So x to the power of 5 minus 3x into x square is minus 3x cube plus x square. So minus plus minus. This is cancelled. Minus 4x cube plus 3x cube minus x cube. This is cancelled. Plus 3x plus 1. plus 1. Say minus x cube. Okay. Here we will make minus 1. Okay. Now you see we will multiply with minus 1. So that minus 1 into x cube minus x cube. Minus 1 into minus 3x plus 3x. Minus 1 into plus 1. It will become minus 1. So that say sign interchange. This is cancel. This is also cancel. Plus. See. This is plus, this is plus, this is not going to cancel, this will become 2. So remainder is equal to, remainder is not equal to 0, that is equal to 2. So hence this is not a factor of this one, this is not a factor of this one. So this is factor, but this is not factor of second polynomial. Okay, we will go for next exercise. So here in this exercise 2.3 question number 3, here obtain all other zeros of this polynomial if two of its zeros are root 5 by 3 and minus root 5 by 3. So here what we have to understand, before going to solve this one, we will see, suppose two zeros if he has given as 5 and 3, for example, this is for example, suppose 5 and 3 are two zeros of the one of the polynomial. Okay, then how we will calculate these zeros? Suppose one polynomial is there, that is x minus 5 and x minus 3 equal to 0. Means if this is the case, then we will calculate as x equal to 5 and x equal to 3. Okay. So x minus 5 into x minus 3 is the polynomial. So how we will calculate x into x square minus 3x minus 5x plus 15. So x square minus 8x plus 15. This is the polynomial. For this polynomial, we have got this factorization, so that we have got these two zeros. Okay, in this way we have solved. We have to go in the reverse order. Now he has given zeros, we have to calculate the polynomial. So polynomial also he has given. Okay, so polynomial he has given, zeros he has given. But only thing is, see here x minus 5 and x minus 3. Okay, only two zeros he has given, and this is the polynomial with a degree 2. He has given the degree is 4. So then there must be 4 zeros, 1, 2, 3 and 4 zeros must be there. And after this, this is the multiplication of this should be equal to this one, this polynomial. So one of the 0 is like this, that is x minus root 5 by 3. Okay, one more is x plus root 5 by 3, because see here, this is minus, this is plus. He has given plus and minus, so that here x minus root 5 by 3 and this is x plus root 5 by 3. And two others are there that we don't know. So this is equal to this one. Okay, so we have to multiply these two first, and see to find this one. For example, this it is A, this is B and this is C. So A into B is equal to C means A we know, C we know. So how to calculate B? B is equal to C divided by A. C means what? This polynomial. So A means the product of these two, then B we have to calculate. So C divided by A we have to calculate. Means what we have to do? We have to multiply these two, that is x minus root 5 by 3 and x plus root 5 by 3. Product we have to calculate. So whatever we are getting product, this x, that to be divided by, this is x to be divided by this polynomial. Okay, then we will get the answer. Okay, we will solve now. So now we will calculate first the product, minus root 5 by 3 x plus root 5 by 3. So x into x square plus 5 by 3 root into x into root 5 minus x into root 5 by 3 minus into minus, minus into plus, minus root 5 by 3 into root 5 by 3. Okay. So here this gets cancelled, x square minus c, root into root, it will be gets cancelled, x square minus 5 by 3 only remaining. So this is the product of this one. So what we are told, this we have got product of two zeros. So product of two zeros, and another two zeros means, that is we have to divide this polynomial with this one. So 3 into x to the power of 4 plus 6x cube minus 2x square minus 10x minus 5. So here x square minus 5 by 3. So x fourth is there, x square will multiply and 3. So 3x fourth minus 3x square into minus 5 by 3. So 3 gets cancelled, 5x square. So 5x square. So this is minus. So minus plus this gets cancelled, 6x cube, okay, plus, see, 5 minus 2, 3x square minus 10x minus 5. So now x cube is there, x square is there, so one more x and symbol plus, so here 6, 6x into x square, 6x cube minus, see here, 6x into minus 5, 6x into minus 5 by 3, 3 2s are, so 5 2s are 10, so minus 10x, so here minus 10x, okay, so this is cancelled, 3x square remaining as it is, this is plus, this is minus, gets cancelled, minus 5, okay, 3x square minus 5, here plus 3, okay, 3 into x square, 3x square minus 3 into 5 by 3, it will be 5 only, so remainder will be 0. So this is the quotient. So as soon as the remainder is 0 means this is a factor of this polynomial. So hence 3x square plus 6x plus 3 is a factor of this polynomial, and we have to find out the zeros. So we have to make factorization this one. 3 into 3, 3 into 3, 9, 3 plus 3 equal to 6. So 3x square plus 3x plus 3x plus 3. 6x we have divided as 3x plus 3x. 3x into x plus 1 plus 1 into, 3 into x plus 1. So here So here 3x plus 3, 1 common, x plus 1 is another. This should be equated to 0. So 3x plus 3 equal to 0. So x is equal to minus 3 by 3. So which is equal to minus 1. X plus 1 is equal to 0. X plus 1 equal to 0. X is equal to minus 1. So minus 1 and minus 1. These two are other zeros. What he has given? Two zeros he has given. That is root 5 by 3 is 1. And minus root 5 by 3 is one more 0. This is total root. And another two zeros are minus 1 and plus 1. These are the two other zeros. This one and this one. Okay. We will go for next one. Here in this question, exercise 2.3, question number 4. On dividing this polynomial by a polynomial of gx, the quotient and remainder were x minus 2 and minus 2x plus 4 respectively. Find g of x. As we know that p of x divided by g of x. Okay, this is the equation. We can write as p of x is equal to g of x into q of x plus r of x. Okay, he has given p of x, q of x, r of x. You have to calculate this g of x. Okay, so g of x is equal to what we have to do? P of x minus r of x first. Okay, then q of x. So in this way we can do. First p of x, this one, x cube minus 3x square plus x plus 2, and we have to subtract this remainder. Remainder is, this is quotient and remainder. This is quotient and this is remainder. So subtract this one, minus 2x plus 4. So x cube minus 3x square plus x plus 2 minus into minus plus 2x minus into plus minus 4. Okay, so plus 2x plus x, this is 3x, minus 4 and plus 2 minus 2. So we will write equation as x cube minus 3x square plus 3x minus 2. This is the equation now. Okay, this one. So we have to divide this one by q of x. This is x minus 2. So x cube minus 3x square plus 3x minus 2, and this divided by x minus 2. Same thing. Here x square, this is x cube minus 2x square. So minus plus, this is cancelled, plus minus, this is minus x square remaining, plus 3x minus 2 is there. Okay, x square is there, x is there, one more x, minus x. So minus x into plus x, minus x square. Minus into minus plus, plus 2x. Plus minus, this is cancelled. 3x minus 2x is x minus 2. So x minus 2, x minus 2. So this is plus 1. 1 into this whole thing, that is x minus 2. So this is minus plus and this is 0. So remainder will becomes 0. Yes, this is a factor. Okay, now this g of x is equal to x square minus x plus 1. This is the answer. Okay, we will go for next one. In this exercise 2.3, in that question number 5, give some examples of polynomial p of x, g of x, q of x and r of x which satisfy the division algorithm. And here in the first portion he has given, we have to give the example for this type of function, that is degree of p of x is equal to degree of q of x. Here we know that the equation p of x is equal to g of x into q of x plus r of x. Here p of x is nothing but dividend and g of x is equal to divisor and q of x is nothing but quotient and r of x is the remainder. Okay, now if we want degree of p of x is equal to degree of q of x, nothing but that is dividend and this is the divisor and this is the quotient and whatever the remaining, it is remainder. So here what he is asking, the degree of this one should be equal to the degree of this one, quotient. Means if these two degrees to be equal means, then this divisor must be divided by the sum of the constant, any constant value to be divided. So then only this degree and this degree will be equal. Here for example, let us consider, let p of x is equal to 3x square minus 6x plus 5. We will take one equation. So suppose g of x it is equal to 3, then we have to divide, that is p of x divided by g of x, means this to be divided by 3. 3 means whatever remaining, that is x square minus 2x plus 1. Okay, 3 is remaining. This is q of x. Remainder will be how much it is, that is 5 minus 3, it will be 2 only. So here you consider degree of this p of x, degree of this is 2 and quotient degree 2 also same. So this is the best example. 3x square minus 6x plus 5 will be the p of x. Okay, then q of x will be x square minus 2x plus 1. This is q of x and the degree of this one and this one are equal. In this way we can write the equation. Second portion, degree of q of x is equal to degree of r of x. So here degree of q of x is equal to degree of rx. Nothing but this degree and this degree to be equal. So now second portion we will take, that is degree of q of x, it is to be equal to degree of r of x, that is quotient degree and remainder degree to be equal. That type of examples. For example, if we take 2x square minus 4x plus 3, some polynomial we will take example. Suppose this is the p of x, then if we divide it by something else, then the quotient degree and the remainder degree to be equal. That he is asking, that type of equation. Suppose p of x we have considered as 2x square minus 4x plus 3. Okay, then g of x what we have to consider, suppose x square minus 2x plus 1, if we take here x square minus 2x plus 1. Okay, so here 2, so 2 will be quotient, 2 into 2x square minus 4x plus 2. Okay, this is cancel, this is cancel. So 3 minus 2 equal to 1. So here 2 will be the quotient and 1 will be the remainder. So quotient will be q of x equal to 2 and r of x equal to 1. So the degree of this quotient and remainder will be, both are equal, because both are constant only, the degree of those equations will be 0 only. So hence both are equal. In the same way, degree of r of x equal to 0. So for this third example, this is the degree of r of x to be equal to 0. For this also the same examples can be given, because see, the degree of this q of x and the degree of r of x both are equal to 0 only. So the same examples can be given, hence you can, or otherwise you can give some other example. This can be taken as homework for you. Okay, so let us go for next exercise.